All right, good afternoon. Today we're continuing with polynomial division and just looking at what we have with polynomial division. Again, there are two kinds we're going to be looking into. And now, yesterday we looked at long division, and I'm going to show you sort of the process of making a segue from long division to synthetic division. Okay, synthetic division being the other approach. And okay, say if you have a polynomial. Okay, so for a polynomial, and I'm going to set up f of x like what I did with that which I used in describing the end behavior of the graph of a function. Okay, so you have so you got a polynomial f of x, and again, so you have leading term, or the highest order term, you have symbolically as a of n x to the n, and we have plus a of n minus 1, x to the n minus 1, and we have ending with a constant case. You have at a naught, and say if you have a polynomial of this type, okay, to be divided by a binomial expression in the form of x minus c. Okay, so you have a polynomial of this type divided by x minus c. Okay, again, first of all, okay, now the long division setup. It's going to be, okay, so you have divided by x minus c. So you're taking that which you have in this binomial, this linear expression. And again, so you're taking into a of n x to the n plus a of n minus 1 x to the n minus 1, and so on. And again, just for the items, so we have with x minus c, okay, so x minus c, again, that is going to be the divisor. And for what I have in the case of the polynomial, okay, that is going to be the dividend. Okay, so what I'm using to divide into, that's the divisor, and what is being divided into, okay, that is the dividend. Okay, and now, this is going to be your long division setup. Now, if I take this linear expression and attain the 0 from this, so if I were to set the divisor equal to 0, in this case x minus c is equal to 0, I have that x is equal to c, and what would happen is that, well, this is going to be the long division setup. It's going to be with the 0 from the divisor. And you're going to have what is going to be the synthetic division setup. It's going to be, okay, and instead of, okay, just x minus c, you're going to take representing the divisor. Okay, you have not x minus c, but instead you're going to have c. And for what we have here, so we have a c, okay, so that's going to be boxed in. And I think Alex has it displayed kind of like in this particular format, but regardless, okay, so you have c, and on the other side, okay, of the barrier, okay, you're going to have just the coefficients of the variable terms. So you have like a of n a of n minus 1, and you continue adding column headings until we get to the constant. Okay. Now, in the case of a particular polynomial division case, so this is the theoretical display. Now, if I'm looking at an application, okay, and let's say that if we have, say, just from starting out with log division, see if I have an expression, if I have 7x to the fourth plus 2x squared plus 1, okay, to be divided by x minus 1. Okay. Or you can write this as a ratio. So you have 7x to the fourth plus 2x squared plus 1 all over x minus 1. Okay. Now, taking what we have here, say through the approach of taking log division, okay, so again your divisor is going to be x minus 1 and for the dividend, okay, now for the dividend you have 7x to the fourth plus 2x squared plus 1, and I want all the degrees in x, okay, to somehow be represented, okay, from fourth order on down to the constant. Okay, so we have, so we got 7x to the fourth. Notice we have in the dividend, the next term is 2x squared, so we are missing an x cubed term. So I want to use a 0 placeholder. Okay, then we have plus 2x squared Notice we do not have a first order x term, so I'm going to use another 0 placeholder. So you have plus 0x, and then finally we have plus 1. Alright, so we have in the process, okay, so we have both the divisor and the polynomial dividend to be in descending degree order. And for the quotient, now the first term, you look at the higher or highest degree terms from the divisor and the dividend. Okay, so if I take x into 7x to the fourth, or 7x to the fourth divided by x, okay, that's going to go 7x cubed times. Okay, so again, so just looking at what we have here, if I distribute 7x cubed over x minus 1, again, you don't have to do the work on the side, but just to kind of show you where things sort of come from, you have 7x cubed distributed over the quantity of x minus 1. So you're going to have 7x to the fourth minus 7x cubed, and these terms will be lined up underneath the like terms from the dividend. So you have 7x to the fourth, we have minus 7x cubed, and again at each stage, okay, now with log division you're looking at row by row subtraction, and the object is going to negate any leading term from the polynomial dividend and anything else that spins off from it as we enter from one stage of log division to the next. Okay, so if I subtract, so we have 7x to the fourth will go out completely, and then we have 0 minus negative 7x cubed, so this will translate to addition. So we have 7x cubed, and I can bring down the subsequent terms. So we have plus 2x squared, we have plus 0x plus 1. Okay, so I took x into 7x to the fourth, and after the first round of log division, I'm looking at now taking x into 7x cubed. So this will go 7x squared times so you have to have like 7x squared over x minus 1. So we have 7x cubed minus 7x squared, and those terms will be lined up underneath what I have from what remains after the interaction between the dividend and the first round long division. So I have 7x cubed minus 7x squared So after this process, okay, so again we have the reapplication of subtraction. So we have 7x cubed minus 7x cubed will go out. Now we got 2x squared, and what's going to translate to plus 7x squared, so this will become 9x squared. Then we can bring down the 0x and the 1. So the first order x term and the constant have not been touched yet. Now for the next round, okay, so I took x into 7x to the fourth, then I took it into 7x cubed, and now taking it into 9x squared. So this will go 9x times. So we have 9x times the quantity of x minus 1. So this will become 9x squared minus 9x. And we'll line these up underneath the corresponding like terms. So we have 9x squared minus 9x. And once again, applying subtraction. So we have 9x squared is going to go out. Now we have 0x, and what's going to be plus 9x. Subtraction of a negative changes over to addition. So we got 9x, and then we can bring down the 1. And now, okay, so we're going from taking x into 7x to the fourth, 7x cubed, then to 9x squared, and finally we have x into 9x. So this is going to go 9 times. Okay, so you have 9 over x minus 1. So this will be 9x minus 9, and those will be situated underneath the 9x plus 1. And so for what we have now, and applying the subtraction, so 9x is going to go out, and we got 1 minus negative 9, so this will be 1 plus 9, so that is going to be at 10. Okay, and I cannot take x into 10. So for what we have left over, okay, is that for this process, okay, we have with the quotient. Okay, so I'm taking how much x minus 1 will go into, again, this fourth order expression. So we have this array of terms. So the quotient, again, we have 7x cubed plus 7x squared plus 9x plus 9. And again, for the number 10, okay, that is going to be the remainder. Okay, and just putting on display, like in a bit of expanded notation. Okay. All right. So you're going to have, like in Alex, you have some situations where you'll be looking at taking the ratio and writing out the quotient, and then you have the remainder over the divisor. So just an expanded form of what we have here. So we have 7x to the fourth plus 2x squared plus 1 over x minus 1. So that's going to be equal to the quotient, which we have at 7x cubed plus 7x squared plus 9x plus 9. And we have, in the case of the remainder, okay, so you got plus 10, and it's going to be over x minus 1. Okay, And just think this would be something akin to like if you took like 3 into 100. Like 3 will go into 100 33 times, but you're going to have a remainder of 1. And think of it like 100 over 3 would be like 33 plus 1/3, like 33 and a third. 33 plus 1/3. Here, you got, think of like this is 100, that is 3, so this is like 33 plus 1 over 3. So you got the remainder over the divisor. So that will be the expanded notation that we have here. Now, so this is long division. Now carrying over to what we have in the context of synthetic division. Okay, so again, we had with okay, so this is a long division. Okay, and I'm just going to sort of restate this. Okay, so the long division setup. Okay, so again, I had x minus 1. Okay, so this was into 7x to the 4th, and I had a missing cubic term. And also a missing first order x term. Okay, so this was your long division setup from earlier, from which we attained, again, the quotient and the remainder. Now, if I were to have used synthetic division, okay, so you got your divisor at x minus 1. And if I were to take the 0 of the divisor, so I would have that x is equal to 1. And in the case of the synthetic division setup, okay, so for the synthetic division, okay, so where I have x minus 1 in the long division, okay, is with the synthetic division representing x minus 1 is going to be the 0, which I'm going to have with the number 1. So the 0 of x minus 1 we have boxed in, and we have on the other side of the barrier. Okay, so we have the coefficients of this dividend. Okay, so I have 7 for 7x to the 4th, and again we have 0 for the missing cubic term. Then I have 2 for 2x squared, and another 0 for the missing x term of first degree. And again, you want the dividend to close out with a constant, so we have at 1. Okay, now where the long division involves row by row subtracting, synthetic division, on the other hand, is going to involve column by column addition. Okay, so in terms of initiating synthetic division, okay, so you look at the dividend. Now the first coefficient we have at 7, and this is in reference to 7x to the 4th. And for the leading coefficient in the dividend in the synthetic division setup, okay, we're going to initiate by bringing this down. So 7 is going to be brought down, and after it is brought down, it's going to be multiplied by the number, the 0, that is situated or isolated. So 7 is brought down, and then we have 1 times 7. So taking the product, 1 times 7 is 7. So this will be brought over to the next column. So we're going to add the values together. So you've got bring down 7. 1 times 7 is 7. 0 plus 7 is 7. And again, we have 1 times 7 is 7. And adding, we now have 2 plus 7 is 9. And 1 times 9 is going to be 9. Then we have adding again. 0 plus 9 comes out to 9. And 1 times 9 is going to be 9. And for the last column total, okay, that is going to be at 10. Okay, so in the case of the last column total is going to be the remainder. Okay, and in terms of what we had before, okay, so again you had your 70201. Again, this was in reference to 7x to the 4th plus 2x squared plus 1. But now for the 7, 7, 9, and 9, okay, this is going to be in reference to what we have with the quotient. Okay, for each round of synthetic division, okay, for the leading coefficient, again, so I'm going from 7x to the 4th in the dividend, but once it's brought down, this 7 is going to be in the quotient, and this will be 1 degree less. So this 7 will be in reference to 7x cubed. The next 7 is going to be 7x squared. This 9 here at the front is going to be 9x, and then we have 9 to follow. So again, if you notice, we had the same quotient. Again, so you have the same quotient. So you have 7x cubed plus 7x squared plus 9x plus 9. And again, we had the remainder to come out to 10. And you still had the same expanded notation if I had to take the quotient and then adding in, okay, have the remainder over the divisor. Okay, and so log and synthetic division, as long as you have a linear divisor, it'll work with both approaches. And let's say that if I were to use synthetic division, okay, so if I were to use synthetic division, and we'll say in this case, we'll say we have 2x to the 5th plus 4x cubed, and say we have all over x plus 2. Okay, and for the synthetic division on this one, okay, so looking at what we have, now this is optional, but just as a visual aid, you can look at what we have, at least just taking what we have and visualizing how this might look in terms of a long division setup. But we're going to solve using synthetic division. So in the case of the long division setup, so we are taking x plus 2 and we have into 2x to the 5th plus 4x cubed. Okay, and as you can see, we have some missing degree terms in the dividend. Okay, so we're starting out at 2x to the 5th. Notice we do not have an x to the 4th term. So we use 0 x to the 4th. And we have 4x cubed. And with 4x cubed as the last term, okay, now we want to get the dividend or the polynomial dividend down to a constant. Okay, so for placeholders, Okay, so we need one for the missing x squared. And we need one for the missing first order x term. And we want to close this out with a constant. So we have it 0. Okay. So this is going to be your long division setup. Now, again, we're going to use synthetic division. And so to set this up in terms of synthetic division, so the divisor, okay, we're going to have it x plus 2. And in the synthetic, I'm not going to use 2 or x plus 2, but the 0 of x plus 2. So I'm going to have at negative 2. Okay, so for the synthetic division setup, okay. So once again, so you have with x equal to negative 2, the synthetic division setup. Okay, so you have negative 2 to represent x plus 2. And then for the coefficients, now we got 2 for 2x to the 5th. Again, have 0 for the missing x to the 4th. And we've got 4 for the x cubed. And we have rounding out with the zeros for the missing square first order term as well as the constant. Okay, all right. Again, where line division involves row by row subtracting, synthetic division is going to involve column by column addition. So we have to start out. Okay, so we got from the dividend. So you have this 2 in reference to 2x to the 5th, and the leading coefficient is going to be brought down. So 2 is brought down. Okay, and what happens to this 2 is going to be multiplied by the 0. In this case, negative 2. So here we have negative 2 times 2. Negative 2 times 2 is negative 4. And this product is going to be brought over to the next column. So I'm going to add these numbers in the second column together. So you have like 0 plus negative 4, which is going to be minus 4. And then we have next round. So you have negative 2 times negative 4. Negative 2 times negative 4 is going to be a positive 8. And that product will be brought over into the next column. So underneath 4, we'll have 4 plus 8 is going to be at 12. Okay, and so after that, taking that sum, we have negative 2 times 12. So this is going to be negative 24. And 0 plus negative 24 is still negative 24. And then we have negative 2 times negative 24. That's going to be a positive 48. And adding 0 plus 48 is 48. Negative 2 times 48 is a negative 96. And for the last column total, okay, we have 0 plus negative 96. So this will be a minus 96. Okay, so we have here for the last column total at negative 96. So we're going to have, once again, the remainder is equal to negative 96. Again, just for what I had originally with the 2 and the 4. Again, this was referencing 2x to the 5th plus 4x cubed. Now for the array of numbers in front of the remainder, okay, this being referenced to what we have for the quotient. Now for the quotient, the quotient is going to be 1 degree less than what we have for the polynomial dividend. So while the 2 here represents what we have for the coefficient of x to the 5th, the 2 that is brought down will be in reference to 2 times x to the 4th. And so just going down 1 degree at a time. So we have 2x to the 4th minus 4 x cubed. And then we have plus 12x squared. Then we have minus 24x. And the final we have with plus 48. All right. And so if I were to take what I have here and write an expanded notation. Okay, so I have a 2x to the fifth plus 4x cubed all over x plus 2. Okay, so I got with the quotient part, so we have 2x to the fourth minus 4x cubed plus 12x squared minus 24x plus 48. And then you could either subtract, but in terms of, so you have adding, so you have with the remainder, you have negative 96. And you have over the divisor. Okay, so that is going to be all over x plus 2. Okay, so you got your quotient and the remainder of negative 96. And again, we have all over x plus 2. Okay, so that will be the, once again, the expanded notation for this brand of polynomial division. Okay, now for the set of problems, okay, I said to be looking into, and we have on page 279, and here we're looking at taking, say, starting out with the long division approach, and for what we have in the case problem number 12. Okay, so we're looking at x plus 3, taking into 3x to the fourth plus 17x cubed plus 20x squared minus 28x minus 48. And again, we're looking at writing what we have in the expanded form. So we have, in this case, right, so you have with x plus 3. Okay, so you have into 3x to the fourth plus 17x cubed plus 20x squared minus 28x. And we have minus 48. Okay, so again, this is going to be the long division setup. Okay, so again, with long division, you're looking at row by row subtracting. Okay, so I have x plus 3 for the divisor. For the dividend, I got fourth order, third order, second order, first order, and constant term. So there's nothing missing. And for the first term, if I take x into 3x to the fourth, or 3x to the fourth divided by x, so this is going to leave us with 3x cubed. Okay, and without working on the side here, I'm going to distribute. Now 3x cubed times x is going to be at 3x to the fourth. And 3x cubed times 3. This is going to form 9x cubed. Again, so with the long division, so if I look at subtracting, so we have 3x to the fourth is going to go out, and we have, for the difference of the cubic terms, so we got 17x cubed minus 9x cubed, so this is going to be 8x cubed. We have plus 20x squared minus 28x, so everything else I'm bringing down. Okay, so I took x into 3x to the fourth. Now, for the next round, for the next term in the quotient, this will be the result if I take x into 8x cubed. So this will be 8x squared. And if I distribute 8x squared over x, again, I'm going to have 8x cubed. 8x squared distributed over 3. Okay, so that is going to be 24x squared. And so looking at taking the difference. Okay, so leading terms will cancel out. Now we got 20x squared minus 24x squared. So we have negative 4x squared. And I can just bring down the negative 28x and the negative 48. Next term of the quotient as I take x into negative 4x squared. So we have a negative 4x. And then distributing negative 4x over all of x plus 3. So we have negative 4x squared. Negative 4x times 3. So this is going to be a negative 12x. And once again, we have with subtracting, so we have negative 4x and what's going to be plus 4x squared, so those will cancel. Negative 28x plus 12x, okay, so we're going to have it minus 16x. And we have minus 48. And for what I have here, and I'm going to have x into negative 16x. And so this will go negative 16 times. Okay, and so you have negative 16 over x is negative 16x. Negative 16 over 3 is going to be a negative 48. And once again, we have with subtracting. So we have negative 16x plus 16x, that will cancel. And guess what? We have negative 48 and what is going to be plus 48. Okay, so that is going to be at 0. And so for what we're going to have for the end result, now the quotient will be the top array of numbers, or I say top array of terms. So you got 3x cubed plus 8x squared minus 4x minus 16. Now there's going to be complete divisibility of x plus 3 into this polynomial since the remainder is going to be at 0. And I'm just going to mention for the expanded notation. Now, I'm not a fan of this, but I know that like with Alex, okay, even if the remainder is 0, it wants you to put 0 on the top. I know it seems a bit excessive or extreme, you know, because the answer is just going to be the quotient. Because there is complete divisibility. But this is just sort of giving, okay, just kind of Alex notation, forewarning, so to speak. Okay. So again, we have with the quotient, again, so you have 3x cubed plus 8x squared minus 4x minus 16. Now this would be your answer, but just like in Alex terminology, you want to add in like with the remainder, even being negligible. So you have plus 0 all over x plus 3. So I'm just going to mention this part here. This would be like referencing some of the expanded notation that you might see for polynomial division in the case of working with Alex. Right. So you have the remainder over the divisor, even if the remainder is 0. Okay. Now in the case of, now for a problem like this, you could use synthetic division. But now, for that which you could not use synthetic division, will be something like what we have in the case of number 16. And in 16, you're going to have the divisor is going to be an x squared minus 3. And the polynomial dividend, okay, so you have x to the 5th minus 2x to the 4th. Then we have plus x cubed Okay, now there's no x squared term specified, so again, we'll be looking at using a 0 placeholder. And then we have minus 8x plus 18. Okay, and let me just copy this, and it's because of this portion here. Okay, so you can't use synthetic division directly. And the reason for this, okay, the divisor must be x minus c. Where x is going to be of first degree. Like if I had x minus 3, I could set this up in terms of synthetic division. But if I had like x to the 1/2, x to the 4th, and even x squared, I cannot use synthetic division directly in this format. Okay. So in terms of what I can take directly, again, you have with the long division. Okay. So I have x squared minus 3. And if I look at taking x squared into x to the 5th, so we have x to the 5th divided by x squared. Okay, so this is going to be x cubed. And I'll just kind of move to the side here. Now for x cubed times x squared minus 3. So this will be x to the 5th minus 3x cubed. And I want to line up each of these terms directly under the like terms from the dividend. Okay, so we have x to the 5th. Notice that minus 3x cubed is not going to be under negative 2x to the 4th. Okay, so just for what we have in the first phase, okay, so we have with subtracting, so x to the 5th will go out, and there's nothing placed underneath negative 2x to the 4th, so I'm just going to bring this one on down. And then we have x cubed minus negative x cubed, so this will be x cubed plus 3x cubed. So we have 4x cubed. And just following through with the rest of the dividend terms that have not yet been touched. So we have the next leading term. Okay, we have negative 2x to the 4th. And if I take x squared into this, so we got negative 2x to the 4th divided by x squared. So this is going to be minus 2x squared. So I'm just going to mention, so for minus 2x squared all over x squared minus 3, so that will be negative 2x to the 4th. Negative times the negative is going to be a positive, so you have a plus 6x squared. So we'll line up negative 2x to the 4th, and also 6x squared. Again, make sure that the same degree terms are lined up. Again, just for the next round, okay, just like negative 2x to the 4th earlier, okay, 4x cubed has nothing taken away from it, so I can just duplicate into the next line, have that as the next leading term. And again, negative 2x to the 4th plus 2x to the 4th goes out, and we have 0 minus 6x squared. So this will be minus 6x squared and we have minus 8x plus 18. And then we have for the next go round, we have x squared into 4x cubed. So the next term of the quotient is going to be at 4x. So distributing 4x over the quantity of x squared minus 3. Okay, so this is going to be 4x cubed minus 12x. So for 4x cubed minus 12x, again, I want to line up under the like term from what I have among the remnants from the subtraction from the dividend at the first stage. Okay, so applying subtraction, so 4x cubed will go out. And then we have negative 6x squared will be brought down. Negative 8x, and what's going to be plus 12x is going to make 4x. We have plus 18 to be brought down. And then we have for the remaining term in the quotient. Okay, so we have x squared into negative 6x squared. It's going to be a negative 6. And just with the distributing, so we're going to have negative 6x squared. And negative 6 over negative 3 is going to be an 18. So again, negative 6x squared. You have underneath the first term at this line, and then 18. You have situated underneath the 18 from the dividend remnant. And we have, in the case of subtracting once more, so we have negative 6x squared plus 6x squared goes out. 4x is untouched, so this will be brought down. And guess what? 18s are going to end up canceling. And guess what? I cannot take x squared directly into 4x since x squared is higher in degree than 4x. So for what is going to happen is that for the quotient, that's going to be the resulting top line. Okay, so you have x cubed minus 2x squared plus 4x minus 6. And the remainder, okay, is no longer a constant. Instead, it is this variable term, which is going to be at 4x. Okay, so in the case of writing out in the expanded notation, so we have it x to the 5th minus 2x to the 4th plus x cubed minus 8x plus 18 all over x squared minus 3. So again, we have at the front, you have the quotient so you have x cubed minus 2x squared plus 4x minus 6, and for the remainder over the divisor portion, so the remainder is at 4x, and so we have x cubed minus 2x squared plus 4x minus 6, and we have plus 4x all over x squared minus 3. Okay. All right, so again, if the divisor, okay, is not with the leading term at x of first order, you're going to be looking at, once again, long division. Okay, now from here on out, okay, at this stage, we'll be looking at translating in context of synthetic division. Okay, and in the case of number 20, okay, so if I'm looking at determining the quotient and the remainder, So for x cubed plus 64 all over x plus 4 okay, so if I'm determining the quotient and the remainder, okay, and so I'm going to use synthetic division on this one, but again, for the long division setup, and the reason I start out with long division setup, okay, is to make sure that if I'm missing any degree terms, I want to make sure I have 0 placeholders in the proper places. Okay, so for long division setup, okay, so we got x plus 4. And taking into x to the third plus 64. So I got x to the third. Notice I do not have a second or first order term in x. So I'm going to use 0 placeholders. So I have plus 0x squared plus 0x. And we have plus 64. Now, I can use synthetic division because the divisor is x plus 4, and that x is a first degree. Okay, so I have x plus 4 is equal to 0, so I have x is equal to negative 4. So with synthetic division, okay, so representing x plus 4, again, I had the 0 value, negative 4. And then we have on the other side of the barrier, okay, so taking the coefficients, so with x cubed, okay, read this as 1x cubed, so we have 1. And again, we have zeros for the missing x squared and first order x terms. And then we have closing out with the constant, which we have at 64. Okay, so again, with synthetic division, you're looking at column by column addition. Okay, so we have, again, the leading coefficient from the dividend, we have at 1. So this is going to be brought down. So bring down 1, then multiply by the 0. So you have negative 4 times 1 is negative 4. Okay, so taking the product to the next column. So we have adding 0 plus negative 4. We have minus 4. Next we have negative 4 times negative 4 is going to be a positive 16. Then we have 0 plus 16 is 16. And then we have negative 4 times 16 is negative 64. And 64 plus negative 64, that is going to be at 0. Okay, and so we have with the outcomes here. So the last column total, okay, that is going to be the remainder. And with the 1, negative 4, and 16 at the front, this being reference to the quotient. And after taking around the synthetic division, again, the quotient is going to be 1 degree less than the dividend. So this one was in reference to x cubed, but this one that is brought down is going to be in reference to 1x squared. So the quotient is going to be x squared minus 4x plus 16. So the quotient, we have an x squared minus 4x plus 16. And again, we had the remainder to be at 0. So this suggests that, or affirms rather, that x plus 4 will go completely into x cubed plus 64 that many times with the quotients. And same thing here. Now we have looking at that which is translatable in terms of synthetic division. Okay, so we now have in this item, okay, so you're looking at a fourth order polynomial divided by a first order divisor. And just go ahead and just take the long division setup. Okay, so for the LD setup, okay, so your divisor, okay, we're going to have an x minus 2 and again we're taking into x to the 4th minus 5x cubed, and we have plus 2x squared, and we have minus x plus 20. Right. And again, okay, so for a rather long polynomial dividend, if I took long division, you'd have quite a few rows in the formation. And so where you can use synthetic division, you can save yourself quite a bit of space to work with. Okay, so with x minus 2, again, x is a first degree, and if I set this equal to 0, so I have the x is equal to 2, I can take this 0 and just provide the synthetic division setup, and thus perform synthetic division. Okay, so we'll have it 2, and we have with the coefficients of the dividend, so you have 1 for x to the 4th, negative 5 for minus 5x cubed, we got 2 for 2x squared, and we have minus 1 for the coefficient of negative x, and then we have closing out with the constant value of 20. Okay, so we have a synthetic division. Again, long division, you have row by row subtracting. Synthetic division, you're looking at column by column adding. Okay, so the leading coefficient, again, we have at 1. So this is going to be brought down. Bring down 1. Now we have 2 times 1 is going to be at 2. And then we have negative 5 plus 2 is going to be negative 3. And 2 times negative 3 is negative 6. So this will be brought underneath the heading of 2 in the next column. And 2 plus negative 6 is going to be at negative 4. Next product, we have 2 times negative 4 is negative 8. And this will be placed under negative 1. And combining the negatives, we have negative 1 plus negative 8 is going to be at negative 9. And 2 times negative 9. Okay, so this is going to be at negative 18. And we have 20 plus negative 18 is going to be at 2. Okay, and so for the end results here, okay, so the remainder is going to be at 2. Now for what we will have in terms of the quotient, again, the quotient will be 1 degree less than the dividend. So we started out with x to the 4th, and now this one is going to signify that we have 1x cubed, and then we have minus 3x squared, then we have minus 4x, and then we have minus 9. All right. And again, the remainder, okay, we're going to have at 2. Okay, now, see, we have in the case of number 30, okay, so we got in this one, so we have a divisor with x minus 3. Okay, just for the long division setup, so I have x minus 3. And that's going to be taken into 2x squared plus x minus 21. And instead of working with long division, if I rewrite the setup where I can perform long division, so I have x minus 3 equal to 0. So representing in synthetic division, the divisor x minus 3 Okay, so we have the number 3. And again, for the coefficients of the dividend, so we have 2, 1, and negative 21. Okay, so again, the leading coefficient we have at 2. If I bring this down, so you got 3 times 2 is 6. And situating 6 underneath the 1. So you have 1 plus 6 is 7. And then we have 3 times 7 is 21. Negative 21 plus 21 is 0. So you're going to have perfect divisibility. X minus 3 will go completely into 2x squared plus x minus 21 since the remainder is 0. And in terms of what we have for the quotient, okay, so for the 2 and the 7, okay, the 2 at the top was in reference to 2x squared, but again, with the quotient, you're taking away a degree from the dividend, so this 2 is now going to be in reference to 2x, and we have followed by the number 7, so we have no remainder. So x minus 3 will go into 2x squared plus x minus 21, exactly 2x plus 7 times. Okay, now, again, we have in 34, okay, this is another one where we can translate from long to synthetic division. Okay, so we have for the long division setup. Okay, so we have x minus 2, and we have taking into a 5th order polynomial. Okay, so you have 2x to the 5th plus 13x to the 4th. And we have minus 3x cubed minus 58x squared. Okay, we have minus 20x plus 24. Okay, so notice we have a 5th order polynomial, and there are no missing degree terms. Okay, and now you could do long division over this one, but it would be kind of a long process, and it would take up quite a bit of workspace. And since the divisor is x minus 2, where x is a first degree, okay, this is where I would say it would be definitely most desirable to use synthetic division, because if you want to save workspace and you can use synthetic division would be the route to go with. Okay, so so representing x minus 2, again, if I take what I have in synthetic division, so representing x minus 2, so we have with the 0 value of 2, and then just taking the coefficients from the dividend, so again I have 2, 13, negative 3, negative 58, as well as negative 20, and 24. Okay, so again, the number at the front from the dividend, I'm just going to bring down. So bring down the leading coefficient. Okay, so you got 2 brought down. Okay, and then to transport what we have over into the next column, I'm going to multiply the leading coefficient by the 0, in this case, which is also 2. So we have 2 times 2 is 4. So this will be shifted over and added to 13. So 13 plus 4 is 17. And then we have 2 times 17 is 34. And then adding negative 3 plus 34 is going to be a 31. Now we have next, we have 2 times 31. It's going to be 62. And negative 58 plus 62 is going to leave us with 4. And now we have 2 times 4 is 8. And we have negative 20 plus 8. So this will be at negative 12. And 2 times negative 12 is going to be negative 24. And guess what? 24 minus 24 is going to be at 0. And believe it or not, x minus 2 will go completely into this fifth order polynomial because the remainder is equal to 0. And in terms of how much x minus 2 will go into this fifth order polynomial, okay, then we have these numbers prior to the remainder will indicate just what the quotients will be. Okay, so for the 2, 17, 31, 4, negative 12, this being reference to 2x to the fourth. Then we have plus 17 x cubed plus 31 x squared and we'll have plus 4x minus 12. Okay, so x minus 2 will go into this polynomial that many times as indicated by the quotient. All right, and now just some items to determine. Okay, and I'll tell you what. Let's say if we use synthetic division, and we'll say that we have here, so if we're looking for the quotient and remainder of, and we'll say that, we'll just say that we have let's say we have x cubed plus 10x. And we'll say we have divided by x minus 2. And say for the next item we'll use line division. To determine the quotient and remainder. And we'll say we have with the divisor. Okay, so we'll say we have x squared plus 3x plus 2. And say we have taking into so 3x to the fourth plus 5x cubed plus 6x squared plus x minus 5. Okay, so use synthetic division to determine the quotient and remainder of this ratio. And then for the other one, okay, now we cannot use synthetic division directly. Okay, since the leading term in the divisor is x squared as opposed to x. So let's see what we get for the quotients and the remainders for these two problems. Okay, just if we go ahead and look into these. Okay, now so for the first item, okay, we're looking at using synthetic division. Okay, now just from the vantage point of like a long division setup. Okay, so you're taking x minus 2 into x cubed plus 10x. Okay, now again we're going to solve by using synthetic division. I'm using the long division setup to make sure that I have, in case I'm missing any degree terms, which I am from the dividend. Okay, so I have x cubed. Okay, now I'm missing an x squared term. So I got x cubed plus 0x squared. Then I have plus 10x. And the dividend does not close out with a constant. So I'm going to reapply another 0 placeholder to make sure all the degrees from 3 on down that we have in x are represented. Okay, so just formatting in terms of synthetic division. So the divisor, I have x minus 2. And if I attain the 0 from this, just set up synthetic division. Okay, so if x minus 2 is 0, then the 0 value is going to be at 2. And so for what we have in the case of synthetic division, okay, so we have from x minus 2, okay, I have x equal to 2. And we have with the coefficients, so from x cubed I have 1. We have 0 for the missing x squared. And I have 10 for 10x. My bad, it should be 10x. Okay, so we have 10 for 10x. And we have 0 for the missing constant. Okay, so we have with the synthetic division. Okay, so leading coefficient from the dividend is 1. Okay, so as I bring this down, okay, so 1 is brought down, and we have 2 times 1 is 2. Then we have 0 plus 2 is 2. 2 times 2 is 4. 10 plus 4 is 14. And 2 times 14 is going to be 28. And 0 plus 28 is going to make 28. Okay. And so we have for the results here. Okay, so we have again. Okay, so we had the last column total is at 28. So we have that the remainder is equal to 28. And for the 1, 2, and 14, okay, those will be the coefficients of the quotient. So we have for the quotient, okay, so the one that's in front of the 2, okay, this is going to make reference to x squared. We have plus 2x. And we have plus 14. So the quotient, we have x squared plus 2x plus 14. And again, we have the remainder to be 28. Okay. Now, for what we have in the case of determining the quotient and remainder for this particular problem. Okay. All right. And again, I cannot use synthetic division directly with the way things are set up. Okay, and for what we have here, so if I go with long division, okay, so we have in this layout, okay, so both sets of terms are in descending degree order, okay, and for the dividends, I got a fourth order, third order, second order, first order term in x, and then closing out with a constant. Okay, so for the first term in the quotients, I'm looking at taking x squared into 3x to the fourth. So this is going to be at 3x squared. And if I distribute 3x squared over x squared, okay, this will be 3x to the fourth. So I'm going to line this term underneath 3x to the fourth. And 3x squared times 3x is going to be 9x cubed. So I'm going to situate this underneath the x cubed term in the dividend. And then 3x squared times 2 is going to be 6x squared. So I'm going to place this underneath the 6x squared from the dividend. Again, with the line division. So I'm looking at row by row subtracting. Okay, so I'm going to have 3x to the 4th will go out. And we have 5x cubed minus 9x cubed. So we're going to have a minus 4x cubed. And we have, next in line, we have 6x squared minus 6x squared. Okay, so that is going to be negligible, but I can just write this as 0x squared just for placeholder purposes. I can just bring down the x and the negative 5. Okay, and we have x squared into negative 4x cubed. Okay, so I'll go negative 4x times. Again, the 0x squared is optional, but I'm just using this for placeholder purposes. Negative 4x times x squared. So this will be negative 4x cubed. Negative 4x times 3x is going to be negative 12x squared. And negative 4x times 2 is going to be negative 8x. Okay. And just looking at what we have at this stage, so we're going to have negative 4x cubed plus 4x cubed. Those will cancel out. And we have 0 minus negative 12x squared. So this will be 0x squared plus 12x squared. So this is going to be 12x squared. And we have x, and what's going to be plus 8x. So this will make 9x. And I can bring down the negative 5. And we have with the next term in the quotient, as I take x squared into 12x squared. So this is going to go 12 times. And distributing 12 over x squared. So this will be 12x squared. 12 over 3x becomes 36x. And 12 over 2 becomes 24. And we have in subtracting. Okay, so 12x squared will go out. Then we got 9x minus 36x. So this is going to be a negative 27x. And we're going to have negative 5 minus 24. Negative 5 minus 24 is going to become a negative 29. And notice, okay, negative 27x is less in degree than x squared. So I cannot take x squared into negative 27x. So for what is going to happen is that, okay, for the quotient, okay, this will be the set of terms at the very top. So this will be 3x squared minus 4x plus 12. And as for the remainder, okay, this is going to be this binomial. And so we'll end up at negative 27x minus 29. Okay, so just kind of looking at this, so you got your quotient and remainder. And again, if I were to take like an expanded notation on this one, so I know that Alex is kind of big on the expanded notation for some of these problems. So for what you would have here, so you got this expression and the divisor into the fourth order polynomial. So you got your quotient, which we will have at 3x squared minus 4x plus 12. And then for the remainder to the divisor ratio, so you have the remainder, so you have negative 27x minus 29, and we have over the divisor, again, which we are going to have at x squared plus 3x plus 2. Okay. All right, and now just for the remaining portions here, and I'm just going to give you just a couple of quick theorems, okay. And they're going to tie in together, evaluating functions for certain inputs. And then we will eventually tie these in with the polynomial division we have encountered. And now, and in the case of the remainder theorem, say if we have a polynomial f of x is divided by, say, the very same binomial, okay, that we've used transitioning from notation in long division to synthetic division. But say if you have a polynomial f of x is divided by x minus c, then the remainder will be f of c. In other words, if you have a polynomial divided by x minus c, and c is your 0, well, guess what? The function value, whenever the input is set equal to that 0, is going to be the remainder. So if a polynomial f of x is divided by x minus c, then the remainder will be f of c. And akin to this, and this is going to be sort of binary here, and this is going to be what is referred to as the factor theorem. Okay, so we have in the case of the factor theorem. Okay, so this is going to be binary. Okay, so from the remainder theorem, if the remainder f of c is equal to 0, then x minus c is a factor of f of x. And if the remainder f of c, however, does not equal to 0, then you're going to have that x minus c is going to be not a factor of f of x. And just like in the case of the synthetic division, whenever you had the last column total to amount to 0, which was the remainder, this affirmed that if you were to take the factor theorem, that the divisor we were working with is a factor of the dividend. Okay, and we'll look a little bit further into the remainder and the factor theorems